Hi everybody, welcome to the Unit 5.1 review video. This is Miss Muse, and Mrs. Suderman will be taking over the second part of this review. So if you hear a voice change, that is why. So let's go ahead and get started. On the first set of directions, asked us to graph the following and identify the domain, range, and equations of asymptotes. Well, looking at these following equations, you'll notice that they are all rational equations. So we need to make sure that we remember what the parent rational equation is. And the parent rational function is y equals 1 over x, not kx. Okay, so, and if you recall from the worksheet we did in class, it had curves in the upper right-hand quadrant of the graph and the lower right-hand quadrant of the graph. And the word asymptotes means lines to which a graph will approach but never touch. And if you notice, the axes are the asymptotes of the parent rational function. So we say that it had a vertical asymptote at y equals 0. At x equals 0. And that's this y-axis right here. That's the vertical asymptote. And then it had a horizontal asymptote at y equals 0. And that's that blue line along the x-axis. Okay, and so when we're starting to begin to graph these and state the domain and range in vertical asymptote and horizontal asymptote, we have to figure out the shifts that happen. And here, this -4 in the back tells me I'm going to shift my horizontal asymptote down 4 units. And for those of you in my class, you'll remember that as dealing with cat. And those of you in any other Algebra 2 class, when I say cat, I mean up and down, and when I say bear, I mean left and right. So this -4 is dealing with cat. So our vertical asymptote is going to be down at y equals -4. Okay, and then our bear, or the shift left and right of our vertical asymptote, doesn't happen here. So we'll see in other problems where it does. So our vertical asymptote stays at x equals 0, or the y-axis. So we can go ahead and write those in. Our vertical asymptote is x equals 0, and our horizontal asymptote is at y equals -4. Now, in order to plot our points, I go ahead and create a little table, and I pick 2 x values to the left of our vertical asymptote and to the right of our vertical asymptote. Well, since it's at 0, I'm going to choose the x values of -2 and -1, because those are 2 x values to the left of my vertical asymptote. And 2 values to the right would be +1 and +2. Now, I'm going to go ahead and plug those into my function. And when I plug in -2 for x, I end up getting a value of -3 for y. And when I plug in -1 for x, I end up getting a value of -2 for y. And when I plug a value of 1 in, I end up getting a value of -6. And when I plug in a value of +2, I end up with a value of -5. So I'm going to go ahead and plot these 4 points that I've come up with in this table. So I'm going to plot -2, -3. I'm going to plot -1, -2. And then +1, -6. And +2, -5. And if you notice, my curves are going to go through those 2 points. And all you're doing is a rough sketch. Remember, your graph is going to approach those asymptotes but never cross it. So when looking at our graph, we notice that it encompasses all x values except for the x value at our horizontal asymptote. So our domain is x is everything but 0. X cannot equal 0. And our range is anything but that horizontal asymptote. So our range is anything but -4. So we write our range as y cannot equal -4. Okay, moving on to problem 2. This -5 right here tells me that my vertical asymptote is going to shift right 5. Because remember, in my class, I refer to any number that's close to the x as bear, and bear is a male, so he does the opposite of what he's told. Now this +2 out back deals with cat, and she's a female, and she does what she's told, so that means that the horizontal asymptote is going to shift up 2. So I can go ahead and from the original vertical asymptote of 0, I'm going to shift it right 5. So I'm going to go ahead and draw that in at x equals 5. And then my horizontal asymptote is going to be at y equals +2. I can go ahead and fill those blanks in. Vertical asymptote is at x equals 5. Horizontal asymptote is at y equals +2. I'm going to go ahead and come over and make my table. And the x values that I'm going to choose are 2 to the left of the vertical asymptote and 2 to the right of the vertical asymptote. And since my vertical asymptote is at 5, I'm going to choose 3 and 4. And then I'm going to choose 6 and 7. And then I go ahead and plug each of these x values into my original equation and find the y values. And when I plug in 3, I get a value of 1.5, or 3/2. And when I plug in 4, I'm going to get a value of 1. And then when I plug in 6, I get a value of 3 for y. And when I plug in 7, I'm going to get a value of 2.5. So I can go ahead and plot these points. So I'm going to plot 3, 1.5. I'm going to plot 4, 1. And then I'm going to plot 6, 3. And 7, 2.5. And then remember, you draw a rough sketch through those 2 points, and you're going to have a curve that approaches your asymptotes. So your graph should look something like that. And your domain is that it's all x values except for 5. So x cannot equal 5 is your domain. And your range is all y values except that y cannot equal 2. Okay, let's move on to number 3. Here, this +4 tells me that my vertical asymptote is going to shift left 4. So it's going to be from 0, it's going to shift left 4, so it's going to be at x equals -4. And then there's no shift in my horizontal asymptote in this case. So my horizontal asymptote is going to remain at y equals 0, or the x-axis. I can even go ahead and write those in. My vertical asymptote is x equals -4. And my horizontal asymptote is y equals 0. So I go ahead over to my table. And remember, I picked 2 x values to the left of my asymptote and 2 x values to the right of my vertical asymptote. So I'm going to choose -6 and -5. And I'm going to choose -3 and -2. Okay, and then I'm going to plug each of these x values into my original equation. So when I plug in -6, I get a y value of 1/2. And when I plug in the x value of -5, I get a y value of 1. And when I plug in negative 3 into my equation, I get a negative 1. And when I plug in negative 2, I get negative 1/2. So now I'm going to go ahead and plot these points. I go to negative 6, positive 1/2, negative 5, positive 1, negative 3, negative 1, and negative 2, negative 1/2. And then I draw a curve through those 2 points and approach my asymptotes. And your graph should end up looking something like that. Now my range is all x values except for negative 4. So, I'm sorry, not my range, my domain. So my domain is x cannot equal negative 4. My range is all y values except for 0. So y cannot equal 0, or y cannot equal 0 is my range. Okay, moving on to number 4. This positive 1 tells me my vertical asymptote is going to move left 1. And then this negative 3 in my equation tells me that I'm going to move my horizontal asymptote, or shift my horizontal asymptote down 3. So I can go ahead and draw those in. Moving left 1 from 0 makes my vertical asymptote at x equals negative 1. And moving down 3 from 0 makes my horizontal asymptote at negative 3. When we write the equations of those lines, they're going to be x equals negative 1, and my horizontal asymptote is going to be at y equals negative 3. I come over to my table and make a table with x values that have 2 left of the vertical asymptote and 2 to the right of the vertical asymptote. So I'm going to choose negative 3 and negative 2, and 0 and 1. And when I plug those into my function, the original equation, the values that I get are the following. Negative 3 gives you a y value of negative 6. Negative 2 gives you a y value of negative 9. When you plug in 0 for x, you get a y value of 3. And when you plug in 1, you get a y value of 0. So when I plot those points, I plot negative 3, negative 6, and then negative 2, negative 9. And that's right off of my graph. And then when I plot 0, 3, and then 1, 0. And then I'm going to go ahead and sketch this graph as it approaches the horizontal asymptotes and vertical asymptote. And it should be, hopefully you should be recognizing the pattern now that my domain is all real x values except for negative 1. So x cannot equal negative 1. And my range is all y values except for my horizontal asymptote, which y cannot have any y values of negative 3. Alright, now we're going to move on to the next section of our review, which is the variation problems. And the directions tell us to use direct variation, y equals kx, inverse variation, y equals k over x, or joint variation, y equals k times x times z, to solve each problem and to show the work. Well, the one thing first thing you need to remember is that k equals your constant of variation. And what you need to remember is the way we're going to want you to set up the general equations for each problem. It should always write the first variable given in place of y. So whatever variable they use first is going to be in place of y. It always equals k. And then if it's direct variation, it goes on top. And if it's joint variation, it goes on top. And then inverse, the variable will go on the bottom. Okay, so it's always the first variable given equals k, and then if it's joint or direct, it'll go on top, and if it's inverse, it goes on the bottom. So looking at number 5, it says the wavelength of a certain frequency varies directly as the velocity v of the wave and the wavelength So it varies directly with the velocity. So we need to, the key word is directly. So we're going to write the variable w, the first variable, equals k. And since it's directly, we put the variable v that it's varying directly with on the top. So there's nothing on the bottom here since there's no inverse variation. So they're wanting us to find the constant of variation k. Well, they tell us a wavelength and they tell us a velocity, so we just plug those in. I'm going to plug 60 in for my wavelength. We're wanting to find out what k is, and then I plug in 15 for v. To get k by itself, I divide both sides by 15, and we end up with k equals 4. Now they're wanting us to write the variation equation. Well, that's the same thing that we have up top, w equals kv, but we are going to replace k with the actual constant of variation value that we found. So the wavelength equals 4 times the velocity. So now they're going to ask us, what's the wavelength when the velocity is 32 feet per second? Well, we are looking for wavelength, so we leave that as w. Our constant of variation is 4, and we're going to plug in 32 for our velocity. And 4 times 32 is 128, and the wavelength is measured in feet. So the answer is 128 feet. Okay, moving on to problem 6. It says the time t it takes a salesman to drive to a sales call varies inversely as the average speed. Well, the key word here is inversely. So our general equation, we write the first variable t equals k. And since it's inverse, the variable that we're dealing with will go on the bottom. So r, the average speed, goes on the bottom. And they want us to find the value of k, and they give us a time, 4.7 hours, and they give us a speed, an average speed. So I'm going to plug in 4.75 for my t value. We're wanting to find out what k is, and then our r value is 50. So to get k by itself, I multiply both sides by 50. And when I do that, 50 times 4.75 is 237.5. So k equals 237.5. That's my constant of variation. Now they want us to write the variation equation. And remember, you just write the general formula, t equals k over r, but instead of writing k, we actually write the constant of variation value that we found, 237.5. So the variation equation is t equals 237.5 over r. In C, they ask us how long it would take him to drive 60 miles per hour, to drive at 60 miles per hour. So we're looking for a time t, and they give us a speed. So we're going to write t equals 237.5, our constant variation, divided by the average speed of 60. And when we calculate that, we get an answer of approximately 3.96 hours. So I'm going to estimate and say about 4 hours. It's going to take them about 4 hours to drive at 60 miles per hour. All right, now I'm going to hand it over on to Mrs. Suderman. Take it away, Mrs. Suderman.